All right, thanks everybody. This is Bill Appleton with DreamFactory Software. There's a lot of situations where you should be building REST APIs. It's a very useful technology. But if you find yourself habitually building new APIs for every new mobile project or web project, that can be a problem. And over time, there can be a lot of bad outcomes with that. So that's what I really want to talk about today is REST API complexity, how it gets started, and how to deal with it. So it starts out innocently enough. Somebody needs to build a mobile application, and so maybe there's a client team who's developing the business use case and speccing out the APIs that they need. And there's probably a server team that's looking at the available data sources and starting to think about infrastructure and security. And then they build a REST API, maybe using some REST API creation tool or other available framework, and it works fine. The mobile app is deployed. The problems can start to creep in when somebody needs to build another mobile app. And you know, the modern enterprise may have hundreds or even thousands of mobile apps. So what normally happens is that the new app won't be able to use the old REST API, which was not written in anticipation of future needs. Also, the old API is often in production, so there's really not a big appetite for rewriting it or modifying it. And so what normally happens is another REST API is written. And then, you know, over time, as you've got turnover in staff or in engineering staff, or maybe there's external consultants or other SIs, or maybe the REST API frameworks change, more and more apps get written and more REST APIs get created. And you know, this is where you can kind of wake up one day and look at your infrastructure and realize it's become very complex. You may have trouble even enumerating all the REST API endpoints. All of these APIs are going to be linked to different data sources running on different pieces of infrastructure. They may have different parameters, different security models, different user management strategies. You know, documentation can be, you know, probably never fully created, is going to be lost or hard to find. And then the whole system is difficult to scale and not very portable. And by portable, I mean moving from, you know, cloud to cloud or cloud to data center, that type of thing. So now, in the old days, APIs were usually behind the firewall, an SOA or something like that. But these are mobile projects in many cases today, and so these are exposed endpoints. And so each one is a potential new security vulnerability. If that wasn't bad enough, it was expensive to do all this server-side software. You had to write it all. And it also ended up consuming a lot of time, or that's my prediction. And you know, when we talk to customers, we see this particular problem a lot, where there's a client-side team, and maybe they're an external team that's specifying the API they need, and then a server-side team, which is more likely an internal team, that's building the API. And there's this negotiation process while the two groups converge on the API that they want to use. And you know, we've seen anywhere between 2 months and 6 months just taken in this process. So you end up with a mess on the back end that's has problems with reliability, security, scalability. It was expensive to build, and it took a long time. Your client developers have to learn a new API for every project, and it's just there's a lot of pitfalls and things that aren't very desirable about that. And when we talk to customers, there's a lot of customers that see this situation developing. There's other customers that are just in the middle of it and trying to figure out what to do. So there's a lot of tools out there and solutions, and some of these get used to try to, in either one way or another, address this problem. So one solution we see is API management software. And I think it can unify the front end of the application platforms or the REST API platforms quite a bit. But it doesn't really address the core problem of back-end complexity, scalability, portability. Another issue is that most API management solutions have an additional proxy endpoint that all the services have to go through. So if you're trying to build a massively scalable API platform, for thousands of mobile devices, thousands of Internet of Things devices, this can give you problems in terms of response time and in terms of scaling the whole system. So another solution we see to dealing with REST API complexity is mobile device management. And so this is kind of, throwing in the towel. You're saying, look, we can't figure out the back end, so we're going to control access to it. And I think this, as more and more mobile devices come out, this is just kind of a losing strategy where, you're one smart client hacker away from a security breach. At worst, and at best, it's just inflexible for, the expectations of your employees that they should be able to use different devices to use different applications, and it really is, again, kind of a Band-Aid to the problem. And so, ironically, the REST API creation tools just let you hit the complexity wall faster than you otherwise would have. API management offers some relief, but doesn't really address the core problem, and neither does mobile device management. So we've been thinking about this problem for a long time, and one thing that we see happening is that things get started off in a bad way when you start with the application, you think about the APIs you need, and you tunnel back to the back-end data sources. I think it's more helpful to go the other direction. Look at the data sources you need to mobilize, and then hook them up to a reusable REST API platform for general purpose application development that you can build all of your applications on. And so, is such a thing even possible? Well, think about, Windows or Macintosh developer frameworks for writing desktop applications. You can write thousands of applications on top of Macintosh or Windows without having to ask Apple or Microsoft for any APIs. What if we could do that with REST? That's kind of where we're coming from with a REST API platform. Here's another example. Think of ODBC and JDBC. These are the middleware connectors for SQL data and Java or PHP. Well, nobody ever needs to rewrite those connectors, almost never, and yet they can write thousands of applications on top of that platform. So this is really, a problem we've been working on for a long time. And I want to introduce my colleague, our VP of Products, Ben Busse, who's going to talk about some potential solutions. So, Ben, over to you.
Great. Thanks, Bill. Okay. Hi, everyone. My name is Ben Busse. I'm the head of products at DreamFactory. And what I'm going to talk about today is kind of first give a little bit of context about the very problem that Bill's been talking about, and then we'll spend probably about 15 minutes or so going through a product demo to show everyone how the open source product actually works in action. So Bill talks about this whole conundrum of building APIs for each new project. To provide a little bit of background for everyone on this, I mean, we as a company actually started out as a company that builds applications, and we still run that business today on a lot of different cloud platforms. So we faced this very problem ourselves because we were building apps on a whole lot of different cloud platforms that had lots of different backends, and we found that this complexity was just really, really hard to overcome. So the technology under the hood of the open source product that we're talking about today, we actually built for our own use internally, and then open sourced that technology about 18 months ago. And so what Bill is talking about when he talks about a REST API platform is actually exactly what we're going to talk about today and demo to everyone on the call. So what do we mean by REST API platform? So this is what we're going to cover today. DreamFactory, the open source project that we're discussing, if you look at this diagram, it's everything that is in orange here. So this is an open source Apache licensed software product that you can install on a server, on a cloud, or on a platform as a service, and it's a runtime platform. So it's literally a runtime LAMP stack, and it does three really key things. The first thing it does is it automatically generates RESTful interfaces or APIs to a whole bunch of different data sources. So you install the product and then you connect it. It securely stores your credentials. So you connect it to a SQL database or maybe a NoSQL data store such as MongoDB, a file storage system such as S3 and so forth, or you can hook into external services. And it provides those APIs for you. So you literally don't have to build your own APIs. You can just start developing applications that connect to your actual enterprise data. The second thing that it provides is a scripting and customization engine, and we're going to demo all of this today so you'll see it in action. This lets you extend the APIs. It lets you literally configure the behavior of what your applications do on the server side. So there's a lot of flexibility there. You can go well above and beyond what the APIs do right out of the box. And then the third area is security controls. So DreamFactory provides everything from authentication mechanisms to single sign-on to Active Directory integration, OAuth integration, and so forth. So you can inherit a lot of the security mechanisms that you already have today. So that's what it is. And then on the front end, your applications, whether they're mobile or desktop or Internet of Things applications, are making RESTful calls, runtime calls to DreamFactory, and DreamFactory is returning JSON. And we provide a whole bunch of software development kits to make that easy. So we'll jump into the demo in a second. And just in technical terms, I just want to kind of highlight what happens end-to-end in a given API call. So you can think of DreamFactory really as a transactional backend for mobile applications or IoT, or even web for that matter. So your application makes a RESTful request to the API. It goes through a security control mechanism. So your users, your end users are authenticating in. And so, they have a session. And then DreamFactory goes through the stages of pre-processing any logic. So your scripts are attached literally to REST endpoints, and the system checks and says, okay, should I run a script? Or if there is one, I run that script. The system runs it. It goes through the API engine. So it's looking at that endpoint and doing, some actions there to actually go and actually make the call to the data store, wherever that data store is, securely. And then on the return, it is running any post-processing logic. So you're getting a JSON packet back or XML, and it's going through and running some post-processing logic. And then finally, you get your JSON response. And of course, this happens very quickly, milliseconds. So it's very lightweight. It's very different from HTML page generation where you have lots of stuff going over the wire. This is compressed JSON moving very rapidly over the network. So before we jump in the demo, I just want to make sure everyone understands open source Apache license. It's on GitHub. There are a bunch of installers, so you can install it on infrastructure as a service. Docker is a very popular option. AWS, Azure, we'll talk through various ways to get it in the demo. Platform as a service is another option. You can really start easily with desktop or server. Just install it on Windows, Linux, or Mac. And I also want to mention if you don't want to install anything, you can just start by going to our website and signing up for a free account, which is like a sandbox. You can try it out and use it, and then install it later once you've given it a try. We'll talk a little bit about portability. So when Bill talks about portability, what he means literally are these. DreamFactory is a back end. So you can move it. You can move your apps between development, testing, and production. You can move the software between development, testing, and production. And you can move all your apps, your services, your data, your schema, everything between any infrastructure. So that's quite advantageous. And then on the security side, I'll demo a lot of that. So you can definitely use all of the security tools that you use today. It's open source. It's, like I mentioned, a LAMP stack runtime. So you can use all of the security, and it actually has a bunch of built-in security, both on the integration side and natively inside the actual platform that you can use. So with that, I'm going to hop into a quick demo. And what I'm going to do is the way I like to kind of familiarize everyone with this is just to run through kind of a use case and kind of point out the key things that a team would do in using DreamFactory. So what you're looking at now is the DreamFactory admin console. So this is the user interface with which you configure everything inside DreamFactory. You go and sign up or you install. Here you'll notice I'm just running locally on my Mac. And you're looking at the top here, a bunch of tabs. So you've got apps and users and roles and everything here. And then on the sidebar, you have various options for that particular top-level navigation. So the first thing you do is you go in and you set up an app. And what an app really is it's essentially an API key. And you can run apps in a couple of different ways. The popular ways, or the most common ways, I should say, are either for mobile, obviously, you would select this option because you're actually going to run the application natively on a device, like you're building an iOS application, or you're using Android perhaps, or some native toolkit to build your application. And you just put in an API name, which is the app name, and then that is used for all of your authentication on the back end. You're using DreamFactory as the back end and calling all of the various REST endpoints. The other option is you can use file storage. So in a traditional, say you're building a web application, you're building an Angular application, let's say, that's connecting to some SQL data behind your firewall, inside of your company. You could either run your application remotely, so select the second option, which I just showed you, or you could host the application inside of DreamFactory in DreamFactory's file storage system. So when we say that DreamFactory is a LAMP stack, what we mean by that is that it comes with a MySQL database default. You can select other databases if you want. I'll talk a little bit about what's coming around the corner in version 2.0 and talk a little bit about that. But you can pick out what you want to use for the default database, and that's for your user management and everything else that's stored. And then it also comes with a file system, so that's quite useful if you just want to host the applications within the platform itself. So the first thing, of course, is you set up your applications. I've got some listed. It's important to understand that you're hosting many applications here. So when we looked at that diagram of App 1, App 2, App 3, App 4, you can have all of these applications running within a single instance of DreamFactory. And you can move those applications from dev to test to production. So you can run instances in a dev environment and a test environment, and then deploy to production and host all of those applications or run them in a given instance of DreamFactory. So if I wanted, I could put many applications in here or just run several. It's kind of up to you how you deploy. So we've got our app set up, and now what we want to do is start to add some services. And this is really the heart of the system. If you walk away from this understanding anything, this is probably the most important thing about the product, which is this ability to easily connect to pretty much anything that you would need on the back end for your mobile application. So you can hook, a remote SQL database up, for example. And what this is doing is, in a few minutes, you just give it an API name, give it your credentials to that database. If I had, for example, a MySQL database running, I just put in my username and password and my host and save it, and then that creates a connection. And it stores the credentials securely, and it automatically produces instantly a very comprehensive API for that particular database. So here you're looking at a bunch of them in a list here, and to add them, I can go in and just pick what I want. NoSQL database is also an option. You can hook up remote file storage, you can hook up email, you can hook up push notifications, and things like that. And I also want to point out you can actually hook up remote web services. So you can go here and put in parameters and your headers, and you can actually customize a service definition, which is a JSON file, and that produces an API for you. So you can inherit some other API that you've already built, and what's useful about that is you get all of the security infrastructure that DreamFactory provides on top of that remote web service. So the idea is to put all of your services in one place and then let your applications and your users then call those services via the platform. It proxies in and lets you access all of that data securely. So here's a list of them. I can have as many services, just like apps, as I want. I could hook up hundreds or even thousands in here if I wanted, and I have one place to manage it all. So that's kind of very high level on how you add a service. Once you've done that, you'll want to hop into the API docs. So when we talked about auto generation of APIs, that's literally what we meant. If I hooked up that my MySQL database, for example, and saved it, I'm storing the credentials securely in DreamFactory. DreamFactory is going out and inspecting that database and providing a whole bunch of different RESTful endpoints. And it's doing this with live API documentation, which I'll demonstrate in a moment. So here are a bunch of API calls for a SQL database. You've got all of your It's a noun-based endpoint with HTTP verbs across the whole thing. There are about 40 different API calls that span multiple records, singletons, schema, schema management, stored procedures, and functions, quite comprehensive. And what's powerful about this is that it's easy to learn as a developer. It's pretty simple to understand. And when you crack these open, you can start to actually see the power of the API because it's completely parameterized. So you can append a whole bunch of parameters to the end of your API calls and start making API calls straight to your data. So I'll give a quick example of that. Just so if we, you hooked up your database and you want to see some live data coming out of your, it could be a legacy SQL database running somewhere. You could just put in a table name and whatever the table name is and start to interact. And what's useful about this is without even starting your development or looking at the SDKs, you can see the request and the response, right? And so this is a very simple use case here where this is the API name. I'm appending a limit to it, and it's returning some data. And then I can start to do things if I'm familiar, with SQL. I can start to add, queries to the call. So now we'll return and append a record. So you can build up these very sophisticated queries, and then you can do things such as, maybe I want to get data from a related table, which is a child table. So I have some contacts, and I want to get some related data about, how do I contact these various people. So this is showing, for example, people whose last name, this is a contacts database, so people whose last name ends with Yang, and then there's another object in the database, which is a different table called contact infos. It's a child object. And so in one API call, I'm getting, querying the data for someone with this particular name, returning a set of fields for that person, and then getting some related data about how to contact them, their home information, their work information, and so forth, which actually spans multiple tables. And so most of what you typically do with a mobile application, you can actually implement very quickly with this type of API and get going. And we'll talk about server-side scripting in a minute, but it's useful to point out that you have a small number of very easy to understand endpoints, and then you have this combinatorial explosion of flexibility, right? Because you can append any number of common parameters to the end of your API calls, which is really good. And everything is wildcarded, so you see these table name in brackets. The system, whatever table name you pass in, it figures out if that's a valid table on the back end and returns it if it is. Otherwise, you'll get an API error. So that's kind of the 40 some odd different endpoints here. And then what's also useful to understand is the way that the NoSQL interface works, for example, as well as file storage. I'm going to cover those three before we hop into scripting. So SQL we just talked about. You can also hook up a NoSQL database, which is quite common for mobile use cases, right? You want to hook up Azure Tables or DynamoDB or MongoDB or CouchDB or whatever NoSQL data store you like. And that is really the same set of endpoints as you would have with a SQL database. And what's nice about that is they're really interchangeable. So you can go from MySQL to MongoDB, write the same application, and the API paths are identical. So that's the other point of portability that we talk about. This abstraction decouples the back-end data stores from the front-end application. They're no longer monolithic. They're decoupled. So you can go and call all of these NoSQL APIs, and once you understand one, you understand all the other ones. So here is about 35 endpoints here. It's basically the same as SQL, except you don't have relationships, for example, and you don't have things like stored procedures in a NoSQL database. And then likewise, S3 or file storage, Azure Blob, or there's lots of different file storage systems, but the paradigm is the same. So you have containers, folders, and files. And file storage is really a subset of NoSQL if you think about it. It's just unstructured blob or document files. So you have the notion of containers, folders, and files, single files, or all files in a folder. And this is quite useful just for making API calls. You want to upload files, download files, display files in your mobile applications. Quite easy to do with this API. So once you've got your APIs hooked up, naturally what you want to do is figure out if you need any server-side scripting. And the scripting engine is pretty straightforward to understand. The system uses the Google's open source V8 JavaScript engine at runtime, so it's very fast. I'll give a couple of examples just to point out what it does. So everything on the left here, these are all of the services that I've added that we saw in the Services tab. And now I can go and say that I have, this contacts database that we have. We're building a little CRM application, let's say, for our salespeople internally, and we want to, do some basic, let's say, 2 use cases. One is just some simple field validation. So when we post a new contact, let's say from our CRM application that's running into our MySQL database, we want to pre-process and just do some simple field validation. So there are lots and lots of use cases, typical of any application you're building today, where you need to implement some kind of business logic. This is a very simple use case of just doing a field validation. So when this particular API is called, contacts.post, this script will run at runtime and intercept that request. And if the first name or last name are null in this example, it will throw an error out back to the client. So that's a simple example of pre-processing an API request. An example of post-processing is like typically the common example is actually a workflow. So here on the post-process, let's go back to contacts.post. So here what we want to do is, let's say that this is another simple example, but we could put in some criteria where we want to, flag a particular contact, or if it's a CRM application, it might be a hot account or something where we want to notify somebody, and we could do that with a push notification or an email. So here you can kind of intercept the response after a database call is made, for example, and then run some logic. And depending on that logic, here we're just going to kick off a push notification, and we're actually going to invoke another API call. So we've hooked in Amazon's SNS, which is their push notification service, and we're subscribing to that. So when that record is inserted from this contacts API call that we talked about, the response comes back, and then it's successful, and then we post a push notification to this path, and then anyone subscribing to that push notification would then get that. And you can put in any sort of logic. This is all just JavaScript on the back end. So you write your JavaScript routine, put it here, and then you're good to go. And we're extending that in version 2.0 for lots of other languages. So like if you have PHP or Ruby scripts or something that you're already running, you can actually invoke those from the server. So that's useful for just reusing what you already have if you want to do that. So that is some quick examples of customizing. I will also point out that there's the notion of custom scripts. So I won't go through a quick example here, but here's a trivial one of adding some numbers, right? This is just to demonstrate the function, but you can write custom scripts. So these can be any type of operation, and you can actually go out and call remote web services with this. So if you have services that you want to call, you can make an API call from your client, and then this script will then go out and do whatever it is that you want it to do, depending on what you write. And of course, you just add this in to your client. It's just another RESTful call. So you're calling script, and then the name of the script, and then some parameters at the end to say that it's a user script, we call it, and then whatever the arguments are for that particular operation. So that's it. If we were doing this little CRM application, we've got our APIs, we've looked at the docs, it's a relational database, we understand the API calls, we write some server-side validation, let's say. And now what we want to do is actually understand how the end users are going to use the application, right? So end users being the people within our company or outside of our company, or maybe their business partners. DreamFactory governs all of that. So you need to protect the APIs that you've created and make sure that users are who they are identity-wise, so they authenticate. So I just spent a couple more minutes before we wrap up just showing how that works. So let's say that we have some sales users in our company. These are internal users, and we are going to grant them, remember we saw in the apps we had all of the different applications, we're going to explicitly grant them access to one or more applications. So they can actually access multiple applications that are running in DreamFactory. And in addition to just the apps, of course, you have to give them access control. So in our little CRM application, let's say that it relies on 4 different database objects in our SQL database, from contacts to contact info, which is the way that we showed in that little API call, how to contact them in various ways. So we explicitly grant different access. We can make certain objects read-only, or make them, not allowed to delete, so forth. Or maybe they can do everything for that particular table. And you can control both direct API access and access to the scripts explicitly. So you choose what you're going to grant. And that is kind of the first level of security that you need to implement. If somebody makes an API call, tries to access something outside of what's explicitly granted here, the system won't return any data. So that's your security is really on the server side. This is not MDM or something where you're trying to control clients. You're controlling everything, as Bill mentioned, at the data, and starting with the data first, and then the applications consume and the users consume that data, and you want to control it on the server. You can also do record level access control. So this is the idea for a given table. So here it's a contacts object. I could add as many different criteria as I want on any fields in that particular database. So a simple example is there's an owner ID that's a field on that contacts table, and I'm going to force that owner ID is equal to the authenticated user ID. So user ID is stored in DreamFactory. The user is authenticated, that particular person has an ID, and that ID has to equal the owner ID. If it doesn't, then it will fail. So this means that I can't delete your records and you can't delete my records, as a simple example of record level access control. So no matter what you're building, you have to, well, for your applications to be secure, you need to have this functionality. You need to either write it or use an open source product, such as we're showing today, to implement that. Otherwise, you're wide open and your data is exposed to the world, which is a bad thing. So that's kind of a high-level overview there. And the other thing, I just want to mention, if you go and try this out, you can go to dreamfactory.com and try it out, sign up for it. And then once you're in there, it's really easy to then download. So I mentioned all of these different packages. You can go and get the Docker package, or go to Amazon and get it there and run it on your own server, which is kind of nice. But you can hook up and connect to your data just to try it out, just with the hosted version that's on our website. So that's a quick demo, and if there are questions, we'll go through that. I just want to quickly cover a few more things. We're at 11:35 Pacific time, so a couple more minutes. So one question that comes up a lot is, okay, I can go get the open source product, that's great, but then how do I install it in lots of places, whether dev, test, and production? You can do that today by installing it manually on different servers. And this quarter, we're about to release, we should have a beta out around the end of June of an enterprise product. So this is actually a different software package, which is not open source, it's commercial. And what it does is it lets you centrally manage many instances of the open source product. So we call the open source DSP for short, so DreamFactory Services Platform. So this management product will let you create, launch, backup, many different instances. You can set up different server clusters. You can have dev, test, and production. And it provides cross-instance reporting with Elasticsearch, Logstash, and Kibana, and a bunch of governance capabilities. We kind of think of this as lightweight API management, really. So you can control how many API calls and how much bandwidth is actually going through the system at runtime. So the benefits of this, we'll have some more webinars coming up to actually show it in action, but this is a way, if you're using the open source product or interested, you should spin it up and get familiar with it. And if you think it's a good solution, you can start deploying in production, but you'll really want to look at the enterprise to get centralized management, integration, and security across lots of different instances of DreamFactory running. Shared infrastructure, so it's a multi-tenant type of model. You can have lots of clusters, but in a given cluster, you're going to be running lots of different DSPs typically. So if you had 100 DSPs, you don't really want to install it on 100 different server clusters. You want to consolidate that so you're using those resources wisely. So that's kind of the idea. Architecturally, it's a different product. So instance deployment, usage reporting, API limits, and throttling. And then it runs or operates clusters, which are web server, app server, DB server, and lets you deploy lots of different instances. On one vector, it's usually dev, test, and production, and the other vector is how you run your development organization from an IT perspective. If you have lots of teams, you're generally going to want to partition across different servers and have different development teams working in isolated environments. So that is a quick overview. Before Q&A, we wrap up. The website is dreamfactory.com. Go check that out to learn more. We covered a bit of it today, but it's rather fast, so there's a lot more material you can dig into there, including the technical resources that are available on the website. Downloads, there's a URL, so all of the places that you can get it are online. We have a partner called Bitnami. They make it really, really easy to install, but if you just go to this URL, dreamfactory.com, developers downloads, you will see all of the options for IaaS, Docker, platform as a service, and desktop/server installs. The docs are public on GitHub. Go have a look, github.com/Dreamfactory Software. The current project is DSB-core, that's version 1.9.2, so DSB core/wiki, and you can see all of the documentation for how to get it running. It goes quite in depth. And version 2.0 is about to come out. We'll have another presentation on that shortly. That will coincide with Enterprise towards the end of June. And then lastly, if you're a developer, front-end developer, API developer, back-end developer, or you're an architect and you're playing with this technology and you have questions, you can go to our forum, community.dreamfactory.com. Ask away. There's a lot of information. People try to help each other out. You can also email support@dreamfactory.com, and they can help you